Hello everyone, welcome back to the channel. Today we are going to discuss the fourth practice problem on linked list, and we are discussing Leetcode problem number 19, remove nth node from end of the list. So the problem says that given the head of a linked list, remove the nth node from the end of the list and return its head. So this is also a good practice problem on linked list, and again there are two approaches to solve this problem. One is iterative and the other one is recursive. In the iterative approach, we can do two traversals. In the first traversal, we calculate the size of the linked list. So let's say that the size of the linked list is m. And we need to find a node which is nth node from back. So the index of this node is actually going to be m minus n minus 1. So what do I mean by the index of the node? This node is going to be m minus n minus 1 node from the front. So the nth node from back is going to be m minus n minus 1 node from the front. So in second traversal, we keep a counter and we keep track of the index of the current node, and once we reach the m minus n minus 1 node, we delete it. So that's how we can solve this problem iteratively using two traversals. Now the second approach is the recursive approach. In recursion, we have two options to perform an operation at every step. We can perform an operation while going above in the recursive stack as we are making recursive calls for a subproblem, or we can perform our operations while going down the recursive stack. Let me explain with an example. Let's say this is our linked list. And let's provide each cell an index so that it is easy to track. And let's say that this is a recursive stack. Now first of all, the recursive function will be called for 0. So let's say that the function is f. So f will be called for node 0. Now this is equivalent to saying that we are actually traversing the linked list, and our pointer right now, our traversing pointer, is at node 0. Now similarly, this node will make a recursive call for the next node, and this is how it's going to look like, and this will be equivalent to saying that our traversing pointer moved to the next node. Similarly, each node will make a recursive call for its next node. So this is how our recursion stack would look like. And eventually we'll reach the last node, or our traversing pointer will be pointing to the last node. Now when we are at the last node, we will actually hit the base case because the next node is null, so we would not make a recursive call. So we will start returning from here. So once we start returning from here, what will happen? We'll keep falling down in this recursive stack to the previous function call. Now as you can see, there are two options to perform operations in this particular traversal. So we could perform operations while going up the recursive stack, or we could perform operations while going down the recursive stack. And if you see that while going down the recursive stack, it is almost equivalent to traversing the list in reverse order, because we are at node 4. Then when we fall to the previous recursive call, we go to node 3, then we go to node 2, node 1, and then finally node 0. So if we are performing operations while coming down the recursive stack, we are actually traversing the linked list in reverse order, and we'll be performing our operations from the end. So what if at each step while coming down in the recursion stack, we keep returning a counter. The counter keeps track of the position of the node from behind, and at every step we increment the counter by 1 and we return it to the previous step. So what do I mean? That the counter is initially 0. Now at each step we increment the counter by 1 and we return it to the previous step. So this step will return a counter value of 1. This step will return a counter value of 2. This step will return a counter value of 3. So 1, 2, 3 is nothing but it is representing the position of the node from behind. So this node is the first node from behind. This node is the second node from behind. This node is the third node from behind. So at each step, when we are incrementing the counter by 1, we are actually getting the position of the node from behind. So as soon as our counter becomes equal to n, we know that the current node is actually the nth node from behind, and we simply delete that node, or we do not add it to the linked list, and we return the head. So by following this algorithm in just one traversal, we'll be able to delete the nth node from behind. Now let's quickly go through the code for this problem. So as we can see that our main method, or the method which is going to be called, is the remove nth from end, and we have got two inputs. So one is the list node head, so this is basically the linked list which is being represented by the first node or the head node, and then the value of n, so we need to remove the nth node from back. Since we are going to use recursion, so we have made a helper function so that we can return appropriate values so that our logic works. So in remove helper, we have passed the head node, and we have passed the nth value, which represents the node that needs to be removed. So as we discussed that we are not going to perform any operations by going above in the stack, we'll make a recursive call for the next node, and we'll perform all our operations while coming back. So that is simply what we have done. So we'll come to the base case later. So here what we have simply done is that we have made a recursive call for the next node. And what is the return type of this helper method? So the return type for this helper method is going to be the counter, as we discussed that at each step we'll be returning the counter. Also, since we need to finally return the head of the linked list after modifying it, so at each step we also return the head of the current linked list. So what do I mean by the head of the current linked list? So if I have this linked list, when I'm falling back in the recursion stack, I'm actually moving in this direction. So when I'm at this point, the head of the current linked list is this. When I fall back to this point, the head of the current linked list is going to be this node. So what I simply need to do, this node should start pointing to the head of the previous linked list. So if I make this connection, I have completed my linked list till now. Now this is going to be the current head of the linked list, and I'm going to return this from my recursive call. When I'm going to reach this node, this particular node is going to be the head of the current linked list. So what I simply need to do, I need to make a connection between this head and the head of the previously returned linked list, which is going to be this node. When I connect these node, I have actually completed my linked list, and this is going to be the current head. That's why at every step we also need to return the head of the current linked list. So that's what we have done. So here we are storing the return value in red. What we are doing in this step is that we are creating a new node. We are updating the value of this new node with the current node's value, and in the next variable of this new node we are storing the reference of the returned head. So the head of the linked list that was returned by the previous step, we are just connecting that head with our new node, and then we are returning, we have incremented the counter by 1, and we are returning the incremented counter, and we are returning the head of our current linked list. Now what is this condition specifically? So in this condition what we are doing, we are checking that the counter returned from behind plus 1, if that is equal to n, then my current node is the nth node from behind. So in that case, I do not actually need to add my current node to the linked list. So if I do not need to add my current node to the linked list, then the head of the current linked list will actually be the head which was returned from my previous step. Because I am not adding this node, so the head would not change. This node does not get added to the linked list, so the head returned from previous step is going to be head for this step as well. So one thing that might be confusing here is that why did I increment the counter by 1 if I'm not adding this node? So just to remind you that this counter is not the node position of the nodes in the new list. This counter is actually the position of the nodes in the original list. So that's why deleting a node in the new list does not make a difference to the position of nodes in the old list. So this counter will always get incremented by 1. So our base case is actually when we have reached null. So when we have reached null, we cannot make any recursive calls forward. Also, the position of this node from behind is going to be 0 because it is actually not a node. So the last node is the first node from behind, and null is actually the 0th node from behind because it's not even a node. And what is the head of the current linked list is null because there is no value or no node in the linked list right now. So the head is going to be null, and the position of this node from behind is going to be 0 because it's not actually a node. by following this recursive method, we'll actually create our complete linked list, and in the end we'll return the head of the linked list that we have created till now. So what we are doing here, in the return value which is returned by this recursive function, we are picking the head of the linked list that has been created till now. Head is stored in the second attribute of this pair, so we are taking dot second and we are returning that head finally from our main method. So the time complexity for the problem is big O of n, where n is the size of the linked list because we are essentially traversing the whole linked list once. And the space complexity for this problem is big O of 1, which is constant space. As we are only using helper pointers and helper nodes, we are not using any additional space. So the space complexity is big O of constant or big O of 1. So I hope you understood the logic behind the problem and the solution for this problem. If in case you still have any doubts, please feel free to drop them in the comment section and I'll try to resolve them. So see you in the next video. Thanks for watching. Bye bye.